Start recording. Good evening, everyone. Again, let us go through this. So today's topic is in total internal reflection and apparent dip. ठीक है ना? मतलब हम इन दोनों टॉपिक्स के बारे में बात करने वाले हैं. TIR, like we know what is called as TIR, total internal reflection, means what is going to happen. Something like internal reflection will happen. With that, there will be total internal reflection. Okay, and apparent depth. But like I think it's done every, like let's take an example. When you go to the washroom in the morning time, so what I used to do, like when I used to go to the washroom in the morning, I just used to see that particular bucket. Okay, so what I used to see, that when I will fill this bucket with water, something like that. Okay, when I will just fill this bucket with the water, and when I am seeing it from top, okay, what I used to feel, that this surface layer, the particular surface layer has little bit risen up. मतलब सुबह सुबह जब जाते हो भाई, तो ये क्या दिखेगा कि ये सरफेस लेवल ऊपर ऊपर उठ चुका है. ठीक है, तो मैं सोचा था कि चलो टच करते हैं, ठीक है, उस सरफेस लेयर को. बट वो तो सरफेस लेयर ओरिजिनल डेप्थ पे रहता है. तो इसका मतलब क्या हुआ कि भाई अगर मान लो हम एक ऑब्जर्वर को एक रेयरर मीडियम में रखते हैं, मींस इफ आई कीप वन ऑब्जर्वर इन द रेयरर मीडियम एंड इफ माय ऑब्जेक्ट इज इन द डेंसर मीडियम, something different physical phenomena are going to arise, and these kind of physical phenomena we are going to study today. Okay, so let us start TIR. Okay, so before going to the theoretical study of TIR, what we want to say, that कि अगर मान लो तुम्हारे पास एक डेंसर मीडियम है, ठीक है ना, दिस इज डेंसर मीडियम. ओके, ठीक, ये मेरा मीडियम 1 है, ये मेरा मीडियम 2 है. ओके, लेट अस टेक इन बुकिश वे. ये मेरा मीडियम 1 हो गया, ये मेरा मीडियम 2 हो गया. लाइट क्या कर रही है? लाइट मीडियम 1 से, दैट इज लाइक म्यू ऑफ 1 is greater than mu of 2, means the medium 1 कैसा है? डेंसर है. मीडियम 2 कैसा है? रेयर है. ठीक है ना? तो हम क्या कर रहे हैं, लेट्स सपोज इफ a light source is there, in which medium? Denser medium, and from which the light is going out. Okay, now if the light goes out, we know that light can travel at any angle. So let's suppose if we are considering that the incidence angle with the normal is how much? Here 0 degree. So if the incidence is 0 degree, what is going to happen, that the refraction angle will also become how much? 0, and light will directly come out from the denser medium to the rarer medium, means this will be the property that will be followed. Okay, now we know that, let's suppose if the light hits at some angle, incidence I, okay, to this particular interface of rarer medium and denser medium, what is going to happen? Light is going to come out. Now how the light is going to come out? It will make some kind of angle with respect to the normal with this. Okay, now to try to understand what is going to happen over here, this R will be more than I. What is going to happen here? In all the cases, the refraction angle will be more than incidence angle, because light is coming from which medium to which medium? Denser to rarer medium. Got it or not? Are able to get me or not? Yes or no? Little bit you can say yes or no. Okay, moving to next point. Now we know that light can even hit the particular, like what can happen, you try to understand, as the particular incidence ray is increasing from some kind of 0 angle to something like that. What is happening over here, that at some angle, at some particular angle, I'm calling this angle as critical angle. Means what kind of angle I'm calling this angle as critical angle. What happens with this critical angle is, when the light hits at critical angle on the interface of denser and rarer medium, instead of going out of the denser and refracted back, like if it refracts in the rarer medium, it is not doing like that. What it is doing, it is traveling. Let's suppose if this angle at the critical angle, if the light hits the surface of the denser medium and the rarer medium, what is going to happen is, it will create an reflection angle of how much degree? 90 degrees. Sorry, refraction angle of how much degree? 90 degree, and it will start traveling on the surface of the water. So I think let's suppose have you seen now, like if you put, let's take any container, and at the end of the container, what you do, fill this container with water. Okay, and in the container you try to glow a red light, not blue light or something like that. Try to glow this light by a red light. What you will observe, that the surface of the water, whole surface of the water has become red. Why it is becoming red? Because of this particular property, because the light is hitting at which angle? Critical angle, and due to that light is traveling on the surface, and due to that what is happening? That refraction angle is becoming 90 degree. Got it or not? Are you able to get me or not? Yes or no? Okay. Now, let's suppose there is a condition that if particular angle of incidence over here, means this angle from the light source to this interface of denser and rarer medium, if this angle is greater than theta angle, means if it is greater than critical angle, what is going to happen? That the light will start traveling inside the medium now. Okay, means it will not be refracted upside or downside. What will happen with the light? It will start traveling inside the medium, and due to that, what is going to happen? Look over here. What is going to happen? That this particular angle, let's suppose if it is hitting at this angle, I'm calling this angle as theta. What is going to happen? That after theta, say if this theta is greater than IC, what is going to happen? It will reflect back inside the medium with a reflection angle of how much? Similar angle of reflection of theta. Remember that this theta is greater than critical angle. Got it or not? Second property which needs to be followed. Are you able to get me or not? Yes or no? Oh, what? Sound clear? Should I think, wait, let me just switch off the phone. Now is it clear? Hello? अभी सही सुनाई दे रहा है ना गगन? गगन हिमांशु? अभी अभी भी वॉइस लो है क्या? अभी सही हुआ? अभी थोड़ा बहुत सही हो गया ना? नो. What is happening यार? Now is it good? I think mic is there. Still it is low. Now is it good? Now I think it will be good. Like, yes. हाँ, अभी ठीक है ना? ओके 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 ओके. वो थोड़ा कभी कभी प्रॉब्लम आ जाता है इसके अंदर, मतलब थोड़ा पिच ज्यादा नहीं पकड़ पाता है ना. चलो तो आगे बढ़े. ये समझ में आया कि नहीं यार? मतलब कि अगर मान लो लाइट हिट कर रही है, मतलब ज्यादा लो तो नहीं था ना? हेलो गगन? ओके ओके ओके, तो आगे बढ़ सकते हैं, ठीक है ना? तो देखो मैं क्या बोला कि अगर लाइट हीट कर रही है एट एन एंगल ग्रेटर देन क्रिटिकल एंगल, व्हाट इज गोइंग टू हैपन? कि भैया ये रिफ्लेक्ट होगी लाइट. ठीक है ना? लाइट परफेक्टली रिफ्लेक्ट होगी. और किस एंगल से रिफ्लेक्ट होगी? तो वो सिमिलर एंगल से, जिस एंगल पे वो इंसिडेंट होगा उसी एंगल से वो रिफ्लेक्ट होगी. रिमेंबर दैट दिस एंगल जो होगा वो क्रिटिकल एंगल से बड़ा होता है. ठीक है ना? तभी ये चीजें पॉसिबल हैं. ठीक है ना? ओके. नाउ लुक ओवर हियर. अब एक बात तो हम लोग नहीं सोचे कि भैया ये मीडियम, ये जो विच मीडियम वी हैव कंसीडर्ड ओवर हियर, ये मीडियम कैसा होना चाहिए? लाइक दिस मीडियम शुड बी व्हाट? इज इट लाइक हाउ मच डेंसर इट शुड, दिस मीडियम शुड बी? Like we, let's suppose if I take a highly denser medium, in case of like something like तुम glycerin ले लो. हिमांशु मिसबा क्या हुआ? कुछ दिक्कत है क्या? ओके 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 ओके. सो लाइक देखो पॉइंट क्या है कि लेट सपोज इफ आई कंसीडर अ मीडियम लाइक ग्लिसरीन और समथिंग लाइक दैट. नाउ इन ग्लिसरीन व्हाट इज गोइंग टू हैपन? कि भैया लाइट तो ट्रैवल ही नहीं करेगी, लाइट इज नॉट गोइंग टू ट्रैवल इन दैट. सो एट दैट केस this particular principle will not be applied. So that means what? We need some kind of range of this particular, some particular kind of denser medium. So what that should be? Huh? Like there are, you try to understand the particular size of the molecules in the glycerin will be very much high or not? Glycerin molecules, yes or no? like they will be bigger than the particular size of light packet, we can say. Okay, so at that case, what is going to happen? Yeah, yeah, because see, if that's what, see, this is called as particle theory of light only, no? That how come people thought that light is a particle? Because this, due to this reason only, when it was traveling, like when it was going inside some kind of bigger, denser medium, what used to happen? Tyndall effect used to arise. Then dispersion used to arise. These are things. How it is going to be possible? How you will break? Tell me. If I will apply some force on you, then only you are going to break or not? Yes or no? Or if I make a contact with you, then only you are going to break? Yes or no? Gagan? Yes or no? So that means what? If it is traveling inside denser medium, light behaves both as a particle and wave. So in the cases of when it is traveling inside the medium, we are going to call it as a particle nature of the light, because what is going to happen, that it will approach as a particle wave. It will destroy. It will, sorry, I told a very wrong word. It will not destroy, but it will try to. What it is going to, its path will be changed. Little bit of energy change you will observe. Word or not? Okay. So due to that, in glycerin molecules are very, very big as compared to the light packets, I'm saying. Okay. Now, when they are big, what is going to happen is the energy will not be sufficient enough to cross that particular molecular level. Does light reflects on, refracts on solid? No, no. Light refracts on. Okay. One good question was there. You know, in UPSC, one question was asked. Okay. See, have you observed the? Huh? Tell me. That's what that's what I'm going to show you now. Wait. Okay. I know where you went. I know in which question you went. That's why I'm making this. Okay. Now consider over here. See, have you heard? If you see all the refraction phenomena, all these refraction phenomena are going to happen in which cases? In the liquids. Yes or no? You will observe mainly like a little bit of liquids. That's why you can define refractive index. Okay. Now, but you observe that even diffraction phenomena is available in the glass, yes or no? But glass is a crystalline solid, yes or no? So how come it is happening in glass? First tell me this answer. How the refraction is happening in glass? Himanshu, Anuj, Gagan, tell me what should be the answer for this? Hmm? Himanshu, बताना. Uh-huh. Mm-hmm. नहीं नहीं नहीं. सोचो सोचो अच्छे से. अनुज, गगन, सोचो. क्या? अच्छा. क्वेश्चन Question is simple. Like refraction phenomena happens only in liquids mainly. But if you observe the refraction phenomena, it is going to happen in glass, which is a kind of crystalline solid. Now, in solids only reflection happens. In liquids, refraction happens. Okay. So the question is, why a solid has this refraction property? How come a light can pass through the glass, which is a solid molecule? No, 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 no. It's not the refractive index. Okay, it is correct. The refractive index is also correct, but the property you try to understand. Wait. You try to understand. Now listen. A glass is called a super cooled liquid. Have you heard now that if you look at the old window panes, what we observe that in the down part they have become very very much thick as compared to the upper part. Yes or no? Yes or no? Gagan? ये सुना है कि नहीं सुना है ना? तो ये इसलिए होता है क्योंकि ग्लास जो होता है ना एक सुपर कूल्ड लिक्विड है, मतलब वो सॉलिड नहीं है. ठीक है, ग्लास को हम सॉलिड नहीं कह सकते. वो उसको उसको हम क्या बोलते हैं, इट इज कॉल्ड एज अ सुपर कूल्ड लिक्विड, विच इज मीन्स जस्ट लाइक आइस इज solid at 0 degree centigrade, glass is solid at normal temperatures, right or not? So now if glass is solid at normal temperatures, that means what? Like if you see the ice cube, if you see the crystalline solids, what is going to happen? Mainly from them, the light can pass easily. Why? Because they have voids inside them. Yes or no? Packing fractions is there or not? Tell me so no. Have you studied packing fraction and all? So what you are going to observe that in crystalline solids there are voids in which light can travel. So therefore here glass is a super cool liquid and light can travel inside this particular glass. Got it or not? When it is going to travel, it will follow which law? It will not follow the normal property, it will follow the refraction property. Got it or not? Yes or no? This is the property. Next thing is that, okay, next thing is that you try to understand, if I just polish this glass by some kind of, let's suppose if I polish this glass from the down, okay, what you are going to observe, that similar glass has now started behaving like a which kind of object, or some kind of reflecting object. Yes or no? Have you seen mirrors or not? Without polishing from the back side, can we get a mirror? No, the answer is no. We need to polish it from back side with a particular polished material like copper, silver material, silver kind of material which have the property to reflect 98% of the lights. That's why you get a perfect virtual image in terms of glass mirror. Are you able to get me or not? हिमांशु गगन अनुज समझ में आ रहा है ना? हाँ, टेल मी गगन. Yeah, kind of, yes. हाँ. No, 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 no. It will see that you try to tell me why these things, these silver things look white to you, because they are reflecting 99% of the lights or not. Tell me, so all the 99% of the light they are reflecting. That's why they are looking like white. If they absorb this 98% of light, they will start looking black. Got it or not? Okay. Now, tell me. Huh? Hmm. White light not only, all the lights which are falling on it. But listen, Gagan, no, no, no. Wait, wait. Listen me. In the universe, in the nature, if the light is passing, if the light can cross the atmosphere, it will definitely split up into 7 different forms. Okay, 14 different forms, not only 7 different forms. It will start splitting into how many forms? 14 different forms of light. Electromagnetic waves are there. Got it or not? So light is not only a white light, it is just the dispersion relation. Okay, dispersion's concept. Got it or not? Okay, if it is crossing our if it is crossing our atmosphere, it has been already distributed. Got it or not? Okay. Your voice is breaking, Gagan. Hello. हाँ 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 हाँ. अरे देखो, मतलब मैं ये बता रहा हूँ, गगन समझो कि जो तुम लाइट कंसिडर कर रहे हो ना, कि मतलब ये व्हाइट क्यों दिख रहा है, ये व्हाइट इसलिए दिख रहा है क्योंकि पूरी लाइट को रिफ्लेक्ट कर दे रहा है. मतलब व्हाइट, ये मत समझो कि व्हाइट में 7 लाइट्स इंक्लूडेड होते हैं. व्हाइट लाइट का तो वो जो वर्ड यूज किया गया है ना, व्हाइट लाइट, ये बहुत गंदा वर्ड है. ठीक है, ये तुम्हें कंफ्यूज करके रख देगा. ये व्हाइट लाइट, ये जो वर्ड है ना, ये बस 9 तक ही रिमेंबर रखो, 9 10 तक. 11th में इसे भूल जाओ. ठीक है, क्योंकि तुमने लाइट की अभी 4 डेफिनेशंस पढ़ ली. एक तो लाइट कैसे प्रोड्यूस होती है, केमिस्ट्री के सॉलिड एटॉमिक स्ट्रक्चर में पढ़ा तुमने क्लास 11th के. ठीक। दूसरा तुमने जब पढ़ा, दूसरा तुम लाइट के बारे में कब पढ़ रहे हो, तो अभी पढ़ रहे हो रे ऑप्टिक्स, जिसमें पार्टिकल नेचर के बारे में बात की जा रही है। सबसे पहले ही बोला जाता है यू आर स्टडिंग द पार्टिकल नेचर ऑफ द लाइट। थर्ड तुम पढ़ोगे वेव ऑप्टिक्स में पढ़ोगे, वहां पे तुम्हें मालूम चलेगा कि अरे लाइट कैन फॉर्म, लाइट इज अ फॉर्म ऑफ वेव्स। फोर्थ तुम पढ़ने वाले हो डी ब्रोगली वेवलेंथ में, जहां पे मैटर वेव्स का क्रिएशन होता है। ठीक है। तो ये सारी प्रॉपर्टीज जो तुम बोल रहे हो कि सर व्हाइट लाइट इमिशन स्पेक्ट्रा सेज दैट व्हाइट लाइट कैन बी डिस्ट्रीब्यूटेड into 7 parts, but it is already distributed. Okay, like from the atmosphere we are getting all these lights. Here this particular case we are studying for which kind of light? Atmospheric lights. We are not studying for any kind of special light. If I say that no, yeah, but yes, so what is the problem with that? So if we are studying, huh, 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 huh. So what will happen? This material, huh, huh, yes, yes. No, no, no. Yeah, point is simple. See, refractive index is defined for which case? It is defined for the traveling of light. When you are polishing itself, how come the refraction will come over there? Okay. If you are polishing itself, the refraction topic will be only removed from there or not? Yes or no? Which topic will be utilized after that? Your topic of. No, 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 no. Absorbs. You are very getting making it very confusion. You are saying absorption means refraction. That is totally wrong. Absorption means black body. Okay. Absorption means absorption of light. If let's suppose if an object is absorbing the light, what it is going to do? Its internal energy will increase. Okay. Thermodynamics. You need to go to thermodynamics after that. Internal energy will increase. Have you heard about photoelectric effect or not? So in photosensitive materials, if light falls, the light energy is absorbed by the particular surface electrons or not. Similar kind of thing. When you are saying that if the light goes, sir, in highly denser medium, what is if you are polishing, that means what? Light has entered to highly denser medium. Now, if it is literally reflecting on the red light, what is going to happen in that? It will absorb all this light and it will keep it as a heat. It will keep it as a energy. It will not let it travel, right or not? Huh? Yeah, that's all. See. You have no, no, no. It will. So, see, listen. What I am saying, you try to please understand what I told about this case. I told that if you take a normal glass slab, what is going to happen? Light is going to travel inside that and it will come out. Okay, like this way. Now, if you just polish this glass slab from the behind, from one side, what is going to happen? Light will reflect from that. I'm not saying that if I have polished it, that then at that case light will travel downside, right or not? Okay, if I have polished it, none of the lights will be traveling backside, got it or not? Okay. So let's suppose if I take this, okay, I think you are confused over here. So let's suppose this is my mirror. Okay. Now, okay, right or not? So this is my thickness of the mirror. If I just make it polish from this behind side, okay, like I just polish this region, got it or not? So what is going to happen if light falls over here? It will just reflect back, got it or not? If I didn't polish this black backside region, what will happen? This light will be able to travel over here because it is a which kind of material? First it is a crystalline solid, then it is a super cooled liquid. That's why main reason is that light can travel. from glass kind of materials. Understood? Gagan, got it or not? Unchanged, yeah, it remains. Okay. Now, if it is observed, it will heat. Yes or no? Solar panel gets heated after that. Okay. Now look over here. So based upon this, so where I was, like we try to understand. Okay, refraction phenomena. So you talk me about glycerin. Why glycerin? Like in glycerin, light can travel. This is the example that if the voids are not there in glycerin, molecules are very very much nearer. Okay, as compared even to the solids. Okay, because it is made up of viscous molecule, viscous liquids. Glycerin is a kind of viscous liquid. So molecules are very, very, very much nearer. Okay. So in that case, what is going to happen? Light can't travel easily. That's why the main reason is that light does not travel in glycerin. Okay. Now look over here. So based upon this, we can try to find out that how much dense material we can utilize. Now we have a rarer medium as medium 2, denser medium as medium 1. In the denser medium, we know that like we try to calculate that how much particular density is required. So for that, we know that for critical angle, I'm getting the refraction angle as how much? 90 degree. And after this only, if theta is greater than, if the incidence angle is greater than this critical angle, what is going to happen? Total internal reflection is going to happen. So for this critical angle, if we can find the density of the medium, we can definitely understand that how much density of the medium will be required. Now look over here. What was given? Medium 1 was there, medium 2 was there. Medium 1 was denser. Look over here. In medium 1, what is the angle? Critical angle is there. In medium 2, refraction angle is there, which is equal to 90 degree. Okay. Medium 1, I'm denoting by mu 1 or mu denser. Medium 2, I'm denoting by mu rarer. Now you know that, like if I want to do something, I need to do cross multiplication. So let's suppose if I want to write, if I write mu denser by mu rarer, what is going to happen? This will give you, first for mu denser we need to consider in numerator which angles? This side angles. Okay. So sine 90 divided by, for mu rarer, sine IC. Got it or not? So therefore, mu denser with respect to rarer is going to be how much? 1 by sine of critical angle. So therefore, we can write that the critical angle or sine theta c or sine critical angle required, if you have a denser medium, the critical angle will be how much? It will be equal to 1 by mu denser with respect to the rarer medium. Are you able to get me or not? Yes or no? Himanshu, समझ में आया ना? हाँ. Yeah, Anuj, Gagan, clear? Oh, now look over here. Based upon this, we can calculate how much is the medium required, how much denser is the medium required, and what angle critical, after what angle TIR is possible. Right or not? Okay. Now we'll try to utilize this. How I'm going to utilize? Wait. Okay. So now look over here. So going to give the heading as, now give the second heading, deviation of light ray. Wait, deviation of light ray due to refraction. Due to refraction. Okay. Now we'll try to understand that how much light is deviated when it is going to get refracted. Got it or not? Like we'll try to calculate this thing, these properties. Okay. So we'll try to utilize the formulas and all. Please a little bit be consistent. Again, I'm telling you one little bit of reconcept. Okay. That let's suppose if an interface is there, if this is medium 1, if this is medium 2, and if light falls like this way. Okay, it goes like this way. Let's suppose if angle is I, let's suppose the angle is 2. So if I write mu 1 and if you write mu 2, then in mu 1 I have a speed incidence angle I, here I have the refraction angle R, here I have speed V1, here speed I have V2. So at that case, just simple trick we need to apply, cross multiplication kind of thing. If I write mu1 by mu2, so for mu1 I need to consider these angles. So sin R by sin I, it will appear that will be equal to what? V2 by V1. Got it or not? So this way you can think like this. Okay. Now, based upon this property, we are going to devise something. Now, you try to understand. See this. So we are considering that let's suppose this is my I'm considering that, let's suppose this is my medium 2, okay, upper part, and this is my medium 1, okay, denser part, okay. I'll write by yellow light over here. Wait. This is my medium 1. Okay. So the denser medium is your medium 1, rarer medium is your medium 2. Okay. Now look over here. What is the property? Mu2 is less than mu1. Now here angle is theta I am considering. Let's suppose it is getting refracted at some angle of theta R. Got it or not? Now look over here. The original direction of incident ray was along this side. This angle is what? The deviated angle. Yes or no? Now look over here. Similarly here also. This is the case when I'm devising this whole theory of physics in two parts. One case is one case is case 1. You can consider case 1. Case 1 when theta I is less than critical angle. These all the cases means the light is going to come outside for which angle of incidence? The angle of incidence for which are less than the critical angle. Now let's suppose second case I am considering when incidence angle theta i's are greater than critical angle. So what is going to happen in that case? That TIR is going to happen, as you know before, as you know earlier. Yes or no? Gagan, Anuj, Himanshu, yes or no? Okay. Now, let's suppose this is theta I. You try to see that this was your original direction of movement, but this is your now what? Angle of, this is your what? Path after the TIR. Got it or not? Now, you tell me one thing. This angle, I am calling this as what? Angle of deviation. This angle is what? This angle is your theta R. Now, you know that this reflection angle will be also equal to the incidence angle, that is going to be theta I, because what is happening over here? TIR is happening. Total internal reflection is happening. Got it or not? So based upon this, we will try to devise this formula. Now look over here. You try to understand that I can put one equation mu1. You know that we can apply. This is medium 1. So mu1 sine theta I is going to be equal to what? Mu2 sine theta R. Okay. Now, based upon this, you can calculate the value of theta R. That is going to be how much? Sine inverse mu1 by mu2 into sine theta I. So, this is the relation that if you want to calculate the angle of refraction, if you are aware of theta I, this the value is what? Sine inverse mu1 by mu2 sine theta I. Now, look over here. This deviation. Deviation is going to be how much? If someone asks you that calculate the deviation in the incidence ray. So in case of deviation, how much is this deviation is going to be? It will be equal to how much? It will be equal to, this angle is going to be how much? It is going to be theta I only, vertically opposite angle. This is how much? Theta R. So therefore deviation is what? Theta R minus theta I. Now you know that what is the value of theta R? Sine inverse mu1 by mu2 sine of theta I minus what? Theta I. This is your relation to find the what? Deviation in case of incidence angle, which is what? Less than the critical angle. Remember this line, this word, incidence angle, which is less than the critical angle. Got it or not? Yes or no? Now, to try to consider, let's suppose we are moving, let's suppose here, medium 1 is water, medium 2 is what? Air. Now you know that for things, for a medium which is air, what is the refractive index? It is equal to what? By sub, it is equal to 1. So that means what? Mu of 2 is going to be equal to how much? 1. What you got as a relation of deviation over here? So deviation is going to be equal to sine inverse. So nahi kya hona sab koi? Himanshu, Gagan? So nahi hona Anuj? Gagan? यहीं पर है ना अभी इंपॉर्टेंट चल रहा है सो साइन इनवर्स म्यू ऑफ साइन थीटा आई minus of theta I. Got it or not? So this is the relation. Okay, and this was the case which was asked in JEE 2020. Okay, got it or not? That how much is the deviation angle when light travels from one medium to another medium? People see what if you will see these options now, that then only it will be, you will be confused. Okay, so now look over here. I'll ask one question based upon this. I'll do some many problems, and there are some questions in IIT JAM, yeah, Himanshu, which were really confusing based upon this. That oil problem. If you see in T4 also, the oil problem, it is very difficult they ask. Okay. Now, you try to see this. If someone asks you that, what kind of equation is this? This is a case of non-linear increasing equation. Can I say like this or not? Tell me yes or no. What kind of equation it is? Non-linear increasing equation. You try to see that when as the incidence angle will decrease or as the incidence angle will increase, what is going to happen? Angle of refraction will be much more farther. Got it or not? So therefore, which kind of angle of which kind of equation it is? First, it is non-linear because sine terms are there. Second thing, this term is predominating. Sine increases as the theta of incidence increases. Got it or not? So therefore, what is going to happen over here? This term is higher as compared to this theta. So therefore, deviation is going to increase as what increases? Theta increases. But the point is, one big point is there. Till when? So before going to that, I'll just do one thing. Second case, that when your deviation is like when the particular object is doing what? TIR. Now when it is doing TIR, what is this deviation? I can write the deviation formula as what? Here 180 degree, or I can write pi minus of what? Can I write pi minus of pi of theta I? Yes or no? Can I write this formula or not? Yes or no? Again, here also the formula of deviation will be similar. Okay, that sine inverse mu of sine of theta I minus of what? Theta I. Got it or not? This formula will be still possible, but the apparent formula which I can get it is as deviation is equal to pi minus of twice of theta I. But here also we can try to prove it. How? Look over here. See this thing? Okay. Try to understand this. Now look over here. It is a non-linear equation. Now when it is non-linear, you try to know that for critical angle, what happens? For critical angle, you know, let's suppose if theta I is equal to I of C, you know that refraction angle is how much? Guys, 90 degree. If refraction angle is 90 degree, what is going to happen at that time? You will have your maximum deviation. Now that maximum deviation is going to be how much? It is going to be sine inverse mu is how much? Let's suppose I'm taking mu as 1. Okay, now here if mu is 1, sine theta IC is going to be how much? Sine theta. Okay, you do not put mu as 1, take this as mu. Here I will get what? Sine of IC minus of what? Theta I over here. Got it or not? And that is equal to theta c. Now sine inverse, you know that what? Sine IC is going to be how much? 1 by mu will get cancelled. So sine inverse mu will appear over here. Sine inverse 1 will appear, and that is equal to how much? Pi by 2. Got it or not? So pi by 2 minus of theta c, you get as what? Deviation maximum until and unless the light has, means this case, this deviation maximum is is this possible till when? Until means till that particular time कि जब तक भैया ये जो एंगल ऑफ इंसिडेंस है वो क्रिटिकल एंगल के बराबर है. ठीक है, मतलब बात को मेरे को समझो कि भैया लाइट अगर क्रिटिकल एंगल तक पहुंच पाती है तो वो क्या करेगी? रिफ्रैक्शन करेगी. जैसे ही वो क्रिटिकल एंगल से बड़ी हो जाएगी वो क्या करने लगेगी? रिफ्लेक्शन, सेकंड केस फॉलो करेगी. सो दैट इज व्हाई मैक्सिमम रिफ्रैक्शन, मैक्सिमम डेविएशन इन केस ऑफ रिफ्रैक्शन इज पॉसिबल हाउ मच? दैट इज इक्वल टू पाई बाय 2 माइनस ऑफ थीटा सी. गॉट इट और नॉट गगन? Himanshu? Yes or no? So if someone asks you in case of refraction, how much is the maximum? Tell me. If someone asks you that how much is the maximum refraction which is possible in case of TIR, is how much? Pi by 2 minus of theta c. Now look over here. Here these properties are going to be changed. Now look over here. Here you have got, okay, what you have got? Look over here, that deviation is equal to what? Pi minus of twice of theta a. Got it or not? And also deviation is equal to how much? Sine inverse mu of sine theta a minus theta I. Now look over here. One thing is there. Okay. One thing is there. Gagan, Anush, and Himanshu. I know you guys are very, very logical. What kind of equation is this? Options are A, linearly increasing. Option B, linearly decreasing. Option C, non-linearly increasing. Option D, non-linearly decreasing. Tell me, everyone. How? Himanshu? Okay. Okay. Uh-huh. और डिक्रीजिंग क्यों? Minus sign, yes. Now look over here. So you know that if I write y is equal to minus of mx, we know that this kind of graphs are actually so this kind of graphs are what? Negative, like linearly decreasing graphs. So similarly over here, you try to see deviation is equal to pi minus theta I. Now one thing is there. What happened actually, like in case of refraction, as the in theta I was increasing, refraction angle was increasing. But here what is going to happen is just opposite, like whatever you have learned is going to happen opposite in case of which kind of graphs in TIR. So as you know that if this at particular theta I, what is going to happen if this, if I consider this theta I here, let's suppose for this theta I is equal to IC, what is happening? TIR is happening. Got it? Or critical means grazing is happening, light is traveling on the surface. Now you know that if little bit angle increases from here, what will happen? TIR will happen with the same angle. Now, if I increase this theta incidence angle, what is going to happen? If I increasing this incidence angle, this angle of refraction is going to increase. If angle of refraction is going to increase, that means what? Where the light will approach? Light will approach towards the surface. That means what? What will happen? Deviation will decrease. So one of the biggest thing is happening over here. Here deviation is increasing. Here deviation is decreasing. Got it or not? So write this point here. Deviation increases. Here deviation decreases. Got it or not? As the deviation is decreasing, one thing is what kind of deviation decrease it is? It is a linearly decrease in the deviation of light ray. गगन ऐसे बायजूस में पढ़ाया है क्या? गगन? ओके ओके, कैसा लग रहा है हिमांशु? सही लग रहा है ना? ओके नाउ चलो अब हम इसको यूटिलाइज करते हैं, इस चीज को हम प्लॉट करने का कोशिश करेंगे, ठीक है, इस टोटल डेविएशन को. सो दिस एक्सिस is a deviation. I'm representing this axis by deviation, which I'm denoting by delta. This I'm representing by theta inclined incidence, okay, or theta. You have to plot the graphs. Now this is the case of theta is equal to theta c. You know that if what is happening, that from the region, you try to see this, in the region of theta less than theta c, in the region of theta less than theta c, what is happening? First, it is a non-linear increasing graph. It will increase to till maximum value of how much? It will increase to the maximum value of, it will increase up to the maximum value of how much? Just pi by 2 minus of theta c. Yes or no? So now look over here. See this, what is happening? I have my particular values, that here deviation maximum in case of theta less than theta c, this is the region of theta less than theta c till here. What is that maximum value it can reach is how much deviation? Pi by 2 minus of theta c. Got it or not? Now how I will plot? In plot like this, it is a non-linear increasing graph. So it will increase like this way. Got it or not? The graph increase like this way. Yes or no? Gagan Anuj? Yes or no? Now look over here. अब आगे बढ़ो, देखते हो क्या कि सेकंड केस में जस्ट अपोजिट होता है भाई साहब, कि यहाँ पे सबसे मैक्सिमम जो पॉसिबल डेविएशन है वो किस एंगल पे होगा, तो वो तब होगा जब तुम्हारा इंसिडेंस एंगल ही एक टीआईआर एंगल की तरह एक्ट करेगा, है ना। एक incidence angle, you try to understand what I told, that if theta I, if incidence angle is greater than critical angle, what is going to happen? TIR is going to happen. So if theta I is itself equal to critical angle, what it is going to do? Like it is a little bit, just 0.0006, it is greater than critical angle. What is going to happen? Total internal reflection will happen, and total internal reflection will happen at which angle? It will happen itself on the critical angle. So that means what? The maximum possible deviation in case of this region, delta max here is how much? It is equal to pi minus of twice of theta. Now you know that if I write this in pi by 2 form, it will become what? I will have to multiply by 2. That means what? It is more than, means the deviation in case of TIR is much more than the deviation in case of which case? Refraction case. Okay, but again simple point is there that deviation will start decreasing as this particular means incidence angle increases, which I have shown over here. Okay, so now look over it how I will plot. So this is the value. What is this value? This is pi minus of twice of theta I. Okay, this value is how much? Pi minus twice of theta c, sorry, not theta c. And what happens? What is happening over here? How to draw the graph? That this increasing, this deviation increases till which value? Till the value of pi minus of twice of theta c. After that, you know that TIR case is going to come, and after that, what is going to happen? This maximum deviation is going to decrease. Which kind of way? Linearly. And this is increasing how much? By which kind of way? Non-linear. Got it or not? So these are the best questions of JEE mains, advanced. Leave it. Mains we are not doing. Advanced and IIT exam. TIFR, love it. Means the TIFR is definitely going to pick up one question from all of these topics which we have done in these two classes. Got it or not? It is definitely 99.9% chances there that it will pick up one question from here. Got it or not? Are you able to get me or not? Yes or no? Gagan, yes or no? समझ में आया ना चीजें? ठीक है यार, अप्रेंटिस कंप्लीट करना था। कल कितने बजे क्लास है? कल ट्यूसडे है ना? कल 6 से 7:30 है ना? ठीक है, देखो ये देखो, ये अप्रेंट डेप्थ वाला सब मैंने, उसके बाद ये देखो क्वेश्चन सब लगा रखा है। ठीक है, सारे क्वेश्चन अभी हमें करने हैं। ठीक है ना? तो कल 1.5 घंटे 2 घंटे की क्लास ले लूंगा, है ना? कल 6 से 7:30 मैं टाइम टेबल भेजा हूँ ना, तो कल 6 से 7:30 लेके बैठते हैं इसको। ठीक है, अपरेंट डेप्थ और इनके सारे क्वेश्चन हम कर लेंगे। ये सारी चीजें समझ में आ गई? कोई डाउट नहीं है अभी, है ना? ठीक है, तो इस सारे चीजों को जाके कंप्लीट करो। तो जो भी कुछ दिक्कत है बताना मेरे को, ठीक है ना? ओके, तो आज मैं अभी डीपीपी अपलोड करूंगा रिफ्लेक्शन का ही, देख लो कैसा है। उसके बाद फिर बनाने की कोशिश करना, और अपरेंट डेप्थ कल कल कंप्लीट कर लोगे तो कल पूरी तरह से अच्छे से वो डीपीपी बना पाओगे, है ना? देखो 2 पेज बहुत नोट्स हैं यार। हाँ बताओ।